Hey, what's up guys? Welcome back to the channel. And in today's video, I just wanted to show you how pointers relate to arrays and how pointers are arrays and how arrays are pointers. So I have a quick example here. We create an integer array. We print the the second element of the array at array 1, and then we declare a pointer and assign just the array to that pointer. So notice I'm not taking the address of that because that would be something else. I'm just assigning whatever this array is, I'm assigning that to a pointer. And then I'm going to also take the second element of that pointer. And I'm going to compile it and run it. And you can see they print out the exact same element. So I can also change this demonstration a little. Let's say I made this the first element of this pointer. And recompile. You can see that it prints out the correct first element. And so the idea that I'm trying to get across here is the fact that this array is actually just a pointer. So I can prove that by writing this if statement. So if the array, so we're just taking, remember, just the array object, not the address of the array, just the whatever is stored in this variable itself. I'm going to compare it to this pointer. If it's equal, I'm going to say they are equal. And if we compile and run, you can see indeed they are equal. So this array, when it's stored in memory, obviously when everything is stored in a computer's memory, it's all just numbers. But when this is stored, this is the same number as this variable. And now you might be thinking, well, what is an array a pointer to? I can also show you what that is. And it is the pointer to the first element of the array. So this right here is the first element, right, which has a value of 1. And each of these elements has its own address in memory because an integer takes 4 bytes in memory. And so each of these numbers will be stored in a segment of 4 bytes somewhere in the RAM at some point when I run this program. And I can show you where those addresses are by printing out the addresses of those elements. So I'll show you that by using something like this. Actually, this is pretty useful if you didn't know it already. There's a nice clean syntax to take the address of an element. You just have the normal indexing operation, and then you just use your address operator, the ampersand. So I've now taken the addresses of each of the 3 elements. I'm going to print them out. And you can see they each have their own address in memory. And if you notice, these addresses are all 4 bytes away from each other. We start with 0C, so that's 12. If you add 4 to 12, you get 16, right? And 16 in hex is just 0x1. So we see that by this place value being incremented by 1, and then the 1's place is incremented by 4 again. So you can see this element is 4 bytes away from this, and this element is 4 bytes away from the previous element. So that just shows you how arrays are contiguous segments. So now that we know the addresses of each of these, I'm also going to print out, if we know the array is a pointer, and all pointers just store a memory address, what memory address is it storing? We're going to print it out right now. We'll print out the array, the address of the array. And then we can compare it to these 3 addresses to figure out, all right, is it actually a pointer to its first element? And when we run it and we compare the addresses, we see that the address that is stored in this array is the same as the memory address of its first element. And that's the essential reason behind why array indices start at 0, because indexing expressions like this, I've also covered in my first C tutorial video. Indexing expressions, for example, if I had array 0, they actually compile to this. If I had array plus 0, and then you're going to dereference this. And one quick note here is that pointer arithmetic depends, so that's like adding, subtracting the pointers. That depends on the size of the element. So for example, let's say I have this int pointer right here, right? The element is an int. We know an int is size of 4 bytes normally. So if we have this as pointer, let's say we had it as pointer plus 2, this would actually be adding 8 bytes. And before I do this whole operation, I'll just demonstrate that to you. So we know that array is also a pointer, so I'll just use that for demonstrative purposes. So we already print out where array is. We're going to print array plus 1. And then array plus 1. Compile, run. And you'll see that this address is actually the same as array of 1, which is hinting at what I'm about to show you. But you can see that array is 4 bytes less than array plus 1. If I did this, I did this minus this. See, it's 4. Right, so this is 4 bytes more because the size of int is 4. That's an element. When you add 1, it's actually gonna add this many bytes. It's gonna add 1 times size of int bytes, which is 4. Aside from that, we're going to go back to what I was talking about earlier, which is the fact that array indexing expressions actually compile to dereferencing the array plus the index. So as I showed you just now with the array plus 1, this showed the same address as the address of array of 1, so the second element, because this expression right here, array of 1, would just compile to this. And if I did any other index here, it would just match that right there. So the reason array start at 0 is because when you take this indexing logic, we have array of 0, and we dereference array plus 0. What do we notice? We notice that the 0 cancels out. And since arrays are pointers to our first element, when we dereference array, we should get our first element. And that is why array of 0 returns the first element. So that's just a little quick tidbit there. That's it for today's array video, and I hope you understand. If you have any questions, feel free to leave them in the comments, and I'll see you in the next one. Thanks for watching.